Hi class, I'd like to go over number 6 from the homework set 4.5 with you. This was a logarithmic equation we were supposed to solve for x. Okay, so I'll give you a moment. This is the equation that I was given. Yours may have looked a little different. Okay, so first thing that I need to do when I'm looking at this logarithmic equation is to get one logarithm on either side of the equal sign. So currently on the left hand side I have two terms with a logarithm in it. I want just one term. So I need to use logarithmic rules to put these together. So what I know is that this 2 can become an exponent. That was one of our rules of logarithms. So I can rewrite this now as log base 4 of 5 minus x squared. Okay. Then I can use the quotient rule to put these two terms together because there's a subtraction between them and they are the same base. So I can say have this be log base 4. The first term goes in the numerator. The second one goes in the denominator. Okay, so we're using our logarithm rules. Now, when you have two logarithms that are set equal to each other with the same base, you can strip off the logarithm in the base. So we're going to just end up with 5 minus x squared all over 3 is equal to 75. All right, now we need to solve this for x. So I'm going to multiply both sides by 3. Then on the left-hand side, I need to actually do that multiplication. So I'm going to do it on the side here. So 5 minus x times 5 minus x. Okay, if I use FOIL, first, outer, inner, last, I get first is 25, outer, negative 5x, inner, negative 5x, last, plus x squared. All right, and then we can combine like terms and put this in the order that we're used to seeing it. So x squared first, minus 10x plus 25. So that's what we're going to have on this left-hand side. Okay, so we have a simple quadratic that we need to solve. So we're going to set it equal to 0 by subtracting 225 from both sides. So we'll get x squared minus 10x minus 200 is equal to 0. Then we can go ahead and factor that, and we get an x and an x equals 0. So we need to make negative 200 when we multiply. So two numbers that multiply to negative 200 and also add to negative 10. So we could do negative 20 and positive 10. So x is equal to 20 is one possible answer, and x is negative 10 is the other possible answer. But we can't stop here. We need to go ahead and check our answer. So let's do a different color for checking. It's really important to check your answer with logarithms because their domain is restricted, and we need to make sure that we're operating within the domain. So if I substitute in x is equal to 20, I get, so let's write that. I get 2 log base 4 of 5 minus 20, so that's where the x was. Okay, minus log base 4 of 3 equals log base 4, 75. Well, we have a problem here. 5 minus 20, that's going to give me a negative. And I can't take the log of a negative. Negatives are not in the domain for a logarithm. So can't take the log of a negative. So that means x is equal to 20 is not a solution. Okay, so let's check negative 10 then. So then we would get 2 log base 4 of 5 minus negative 10 minus log base 4 of 3 equals log base 4 of 75. Okay, so the minus becomes a plus positive. So I get 2 log base 4 of 15 minus log base 4 of 3 equals log base 4 of 75. Now I can use my logarithm rules to condense the left-hand side and see is it in fact equal to the right-hand side. So I'm going to take this 2 and put it back as an exponent. So I'm going to get log base 4 of 15 squared minus log base 4 of 3 is equal to log base 4 of 75. Okay, then the left-hand side we can consolidate using the quotient rule. So log, or we can do 15 squared at any time too. But let's do the quotient rule next. So log base 4 of 15 squared over 3 is equal to log base 4 75. This is what we're checking out. Is this the case? And on the left-hand side, if we do 15 squared and divide it by 3, you get 75. So that means x equals negative 10 is a solution. All right, long problem. I hope that this helped.